think this is a really tricky question. I've never seen anything quite like it, and that's what makes it the most difficult thing. And it's about, it's trying to deal with a completely unseen problem, work out what it really is asking. We've got n distinct lines in a plane. That essentially means they're on a piece of paper. It's not like they're going throughout 3D space, which is a different sort of problem. They're just on a flat sheet of paper, and then we're told that one of them intersects exactly five of the n lines that we have, one of them nine, and one of them 11. How can we find the smallest possible value of n? I think the approach here is not to say start with the largest, but start with the smallest value and see if it is possible to do. In fact, for us to have n lines and one intersects exactly n 11 of them, we're definitely going to have n greater or equal to 12. That immediately comes out of it. Now, we might have some lines sort of intersecting in the same point, but that doesn't really help because each line is still intersecting two other lines, even though it's not about the points of intersection, it's just whether they intersect. So how can we get different amounts of intersections? Because if you sort of just start drawing them randomly like this, which you might be tempted to do, well, each of them are intersecting in three places. How can we reduce it, even then, it's now intersecting four. But if you draw one that's parallel, then suddenly you see that these two don't intersect. And so parallel lines are at the heart of this problem. And this piece of information gives us our first little bit of like insight into how to go about solving it. So for one of the lines to only intersect five of the n lines, we're going to need to have seven of the 12. Remember, we're trying out 12 and seeing if it works. If we show that it can't be possible, then we'll work at 13 and so on. But it makes sense to start with the smallest number and see if it can work. So we could put seven parallel lines next to each other. Because then, as long as I draw, put another five in, I can put it in however I want, as long I'm just making sure they're not parallel to the original seven and this one here. Then, if I take one of these seven parallel lines, one, two, three, four, I see there's 5 points of intersection. I've managed to get it. So we've kind of satisfied that condition as long as we can make these seven. And this is going to help with the nine. We'll come back to the 11 actually. I think we'll be okay with the 11. Right, the 9 is going to be another thing to think about. So just like 7 parallel lines then guaranteed us 5. Okay, what if we did 12. What if we had 3 other ones that are parallel? Because then they're going to intersect um, the 7 that we have. They're not going to intersect each other though, and obviously they're not going to intersect themselves. So we can kind of minus 3 from 12 and it's going to work out. Let's say I then draw one sort of like that. What am I up to? I'm up to 11 now. Let's just see where we are, okay, before I add my final one. So we know for the horizontal lines, we've got one, two, three, four, and we're going to get a fifth in a minute for the other point of intersection. In fact, I guess I might as well draw it in. Maybe I just draw it coming down vertically. Okay, and obviously I would have to then sort of extend this and show that there's a point of intersection there. Okay, yeah, I think that's complete. Um, okay, right, it's not, well, I've drawn it too close really, but there's going to be a second point of intersection here. Let me move it along slightly. Okay, there we go. Right, so I've managed to get my 5. Now I've got my um, other 3 parallel lines. See, they're going to go through 1, 2, 3, 4, 5, 6, 7, 8, 9. They just don't intersect with themselves and the other two that are parallel. So I've managed to get the 9. And then I've got 2 other lines. It doesn't really matter what's going on with them, but actually they can't be parallel. That's quite important. But let me take this one at an angle. I've got one, so they're going to intersect all the remaining 11. One, two, three. They're actually intersecting 2 lines at that point. 4, 5, 6, 7, 8, 9, 10. Wait, I think I've counted too many there. Let me just start again. Sorry, nearly there. So it's intersecting the horizontal and the vertical here, so 3. Then it's intersecting that one and that one, so 5, 6, 7, 8, 9, 10, 11. Okay, I just somehow miscounted before. So that one there is managing to do 11. The green one is managing to do 9. And the red one is managing to do 5. Oh, that is a bit mind-blowing, I think, but it is possible to do it with 12. So just to recap, like how do we go about solving this sort of problem? Recognize that because one of the lines has to intersect exactly 11 or more, then there's got to be 12 or more lines. Rather than sort of just drawing 15 lines or anything and seeing if it's possible, start with the lowest and see if it is possible. If not, why not? Why would we have to add extra lines? Think about how we can get these these 5 points of intersection for one of the lines. We're going to have 7 of them that are parallel, so that we only get 5 points of intersection with the other 5 lines that we have. Then to get 9 for one of them, we're going to have 3 that are parallel, so they don't intersect themselves or the other 2. And then just draw any other line, and we'll manage to get to the 11. Okay, well done if you managed to get that. It's a tough question. Hopefully my explanation makes sense.